Today's lesson's on inverse functions. First, let's look at a few steps for when we're going to solve inverse functions. First thing we need to do is change f of x to y. That is, if we have an f of x. If we don't have an f of x, then we don't have to switch it. That could be g of x to or h of x, and that will still switch to y. Okay, once we've switched that to y, we switch x and y, then we solve for y, then we change y back to f of the inverse of f of x, or the inverse of g of x, or the inverse of h of x, whichever variable we have. So let's look at a problem. We have f of x equals 4x minus 6. First step is to change f of x to y. Then I want to switch x and y. And now I want to solve for y. Here I'm going to add 6. That'll give me x plus 6 equals 4y. And I'm going to divide by 4. And I could divide by 4 the whole left side. Or, let's look at another way to do it. I could divide each individual term by 4. Here we're going to have 1/4 x plus 6 divided by 4 can be reduced to 3/2 equals, and then I'm going to switch to inverse of f of x. Now I could also get the inverse of f of x first. Change here, back to inverse of f of x. These two things mean the same thing. So the black and the blue here, they mean the same thing. They're both equal. You could see either one. Okay, they both mean the same thing. You need to know that. Okay. First thing we need to do is change f of x to y. Now we're going to switch x and y. Now we're going to solve for y. I have a fraction, so I want to multiply by the denominator. It gives me 5x equals negative 3y plus 2. Now I'm going to subtract 2 on both sides. I have 5x minus 2 equals negative 3y. Again, here I can divide by negative 3 the whole thing or each individual term. Negative divided by negative is a positive. And then the last thing I want to do is to switch the y back to f of x. Could have also had this written as 5x plus 2 all divided by 3. Either one, they mean the same thing. And now let's go to check this using our calculator. So to check this using my calculator, first thing I want to do is put my problem into y1 and my answer into y2. Next thing I'm going to do is go to my table. Remember from Algebra 1 that inverses mean that I switch x and y. So I want to pick an ordered pair, actually two ordered pairs from x and y1. So I have negative 1, 1. Remember, we're going to switch the x and the y, so now I have 1, negative 1. And I want to find another ordered pair. And I do not like 0 2/5 because it's hard to find 2/5 in my calculator. Okay, I found another ordered pair. Was 4, -2. So it was -1, 1. Switch to 1, -1, and -4, 2. So now I'm going to find these two new ordered pairs, and I want to find them in X and Y too. So is 1, -1? Yes, that's there. And -2. -2. +4 is there. So both my points are there. So that means I've done this correctly. If one of the order pairs is not there, that means we've done something wrong, and you want to go back and check your answer. And let's look at this problem. First thing we want to do is switch the f of x to y. We want to switch x and y. And now I want to solve for y. Add 3 to both sides. Get x plus 3 equals y squared. And remember, now we want to get rid of the square, and the opposite of square, or the inverse of square, is the square root. And we take the square root of both sides. Remember, when we take the square root of both sides, we want to put the positive and the negative. And now I want to switch the y back to the inverse of f of x. And then we want to check. And you can check on your own. Example 4, determine if these two functions are the inverse. So I need to take the inverse of f and see if it matches with g. And if it does, then I want to take the inverse of g and see if it matches with f. So change f of x to y. Switch x and y. Solve for y. X minus 3 equals 2y. Here I don't have a fraction in g of x, so I'm going to want to divide each term by 2. And that gives me 1/2 x minus 3/2 equals y. That does not match g of x, so these two functions are not inverses of each other. All right, let's look at example 5. Now, these two inverses. So we're going to switch f of x and y, switch x and y. We don't like that fraction, so how could we get rid of it? We could multiply everything by the denominator. That'll give us 2x equals y plus 10, because remember we need to distribute that 2. Now we're going to subtract 10 on both sides, and we get 2x subtract 10 equals y. That does match g of x, so now I need to come over to g of x and switch g of x and y. Switch x and y. Solve for y. I'm going to add 10 to both sides. I get x plus 10 equals 2y. Back over here, I don't have one big fraction, I have a small one, so I'm going to divide each term by 2. X divided by 2, that's the same as 1/2 x plus 10 divided by 2 is 5 equals y. That matches f of x, so these two are inverses. Yes, they are inverses of each other. Again, we could check these by putting f of x into y1 and g of x into y2 and finding our ordered pairs. So now we're given a graph, we're not given any equations, so we want to see if these two functions are inverses. So I'm going to take a couple points or ordered pairs off of the red graph. So I see here that I have an ordered pair of 0, -3. And I also have an ordered pair of 2, 1. You could have selected a couple other points if you'd have wanted. Now I'm going to switch the X and the Y. So I have -3, 0. Is that ordered pair on blue's graph? Yes, it is. Is 1, 2 on the blue graph? Yes, it is. So these two are inverses of each other. Let's look at these two. So I'm going to start with the blue. I could start with the red. I'm going to pick two ordered pairs. I have 1, -1. And I have 2, -4. I'm going to switch the X and the Y. That gives me -1, 1 and -4, +2. So I'm going to look for these two new ordered pairs on my red graph. -1, +1. That one is on the blue graph, the red graph. Now I want to check, is -4, +2 on the red graph? No, it's not. So these two are not inverses. That's why it's very important that we check at least two ordered pairs and not just one. If we'd only checked one, we possibly could have thought that these two were inverses of each other. Here's some problems for you to try on your own. Here's some more problems for you to try on your own.